Hello, Assalamualaikum. My name is SYAZANI binti NAZIR, and with my friends NURUL, EDANI binti SULAIMAN and Lim Wipeng, we will present about our assignment 2 for Intelligent Control System subject. For the introduction, recycle is a process of using an item that cannot be decomposed. Recycle are significant with the 3R concept, which is reduce, reuse, recycle, where it helps on how to manage waste properly without causing any harm to the environment. It will help to preserve the natural resources, reducing greenhouse gas emission, conserve the energy, and reduce pollution. Recycling has become more important, and the technology to separate the recycled material are needed. In this assignment, a process of recyclable material classification by using convolution neural network, which is CNN, is being made.
Hi, a very good day to Doctor. My name is Lim Wipeng. The metric ID is AE170106. I will demonstrate how to using a Google Colapse to train without the pre-trained model. Step 1, connect to Google Drive. Okay. Step 2, we feed dataset directory. Okay, we're using this commands. Okay, we will copy here the path. We just go to the recycle parts. Okay, then we just copy the path and then paste in here. Okay, and step 3, we create a trend and validation data directory. Then for the trend underscore dir, we can find we just copy it here the trend directory. Okay, you copy the path and then paste here, same as the previous step. And then the can underscore trend underscore dir also same. We just expand this and then copy the can path and paste here. Same process will be proceed with the rest. Okay, then we just print the can print length, print trend length, and then the pad trend length, and the can VL length, the pad VL length, and then the can.p test length. Okay, then we proceed to import the library, the TensorFlow, the ASDF from TensorFlow.class.optimizer, input the RMS prop, then from TensorFlow.class.preprocessing.image input image data generator. For the class.applications, import VGG16. Okay, for the step 4, we construct a CNN model. From here, we just we can develop ourselves. Okay, using this coding. Okay, at the first we create the COV 2D, and then we using activation of RAZALI, input underscore set. This is our size 150, and then the tree actually is our 3 channel, the RGB channel. Then next we max pooling 2D, and then next for the COV 2D, the max pooling again, and then repeated, and then the last we're using a fractals. Now dense activation with RAZALI, and then dense CMOS. Okay, then we form the architecture, we'll compile it. Then we're doing the summary. The model.summary actually is mean by we can summarize all the architecture of the system. Okay, but from here actually is same as the here. Okay, then we proceed with step 5, pre-process the input data. We rescale all the image, and then we target side we put 150, and the batch side 20, Then we're using a binary for the class mode. The validation, same as the validation generator, and then the test generator. Okay, use the same process. Okay, then we step 6 will start the training process. We're using the step per epoch 20 and then epoch 30. Okay, these are our trainings. Then step 7 we plot the outcome. We plot a graph. Okay, this is our graph. We can say that for the training accuracy, overall is actually greater than 0.65 and above. We can see clearly accurate 0.65, okay, and above. And then most of it already achieved the 100%. Then for validation accuracy, fluctuating, okay, but overall is over than 0.8, okay. And then for the training and validation loss, actually quite good. The training loss is below the 0.1.5, 1.5. Okay, validation loss roughly below than 2. Okay, then we're testing. We set the model to as the M1.H5. Okay, then we're using the same, the test theta gens, and then rescale, and then we're using a 10, the target size 150, and then the batch size we're using 20. The binary we're using a class mode SN as the same here. Okay, then we proceed with the summary to do the M1.H5. You can see all the architecture of the systems. Okay, and then we'll proceed with the model.evaluate underscore generator, the test generator. We're testing the test generator, and we're doing a step 1. Step is 1. Then we can find the two variable here, and then we can get a 0.65, which is our pets. Actually, it's for cans, and then 1 is for pets. Okay, then we proceed with the training with the pre-trained model VGG16. Actually, same as the without the pre-train, we connect to Google Drive, and then we feed the dataset directory. We're using a send recycle at here, recycle here. Then we'll copy the path and paste here, and then we'll create a trend and validation directory. Also should be same. Okay, we just paste. Then at here we don't need to test the test file, so we remove the test directory. So we process as usual. Then we input the library, same as the without the print train. We'll input the VG16. Okay, then step 4, we construct pre-trained model with BGG, then COV underscore base equal to tf dot class dot application dot VGG16. We're using this VG16, and then we're using the ImageNet, and then the include underscore top equal to false. Actually, it's meant by the we're going to remove the VGG16, the last layer of the VGG16, because the last layer of the VGG16 is used for thousands of category. Because in our case we just only got 2 category, so there's no need, so we just remove it. Then for the input underscore shape, the site is we're using the 150, and then 3 is our RGB channel. Then the COV underscore base dot trainable equal to false. This means by we no need to train the VGG16 because it's already trained, so we just skip the training of the VGG16, so we put false. Then COV underscore base dot summary will print out all the VG16 architectures. Okay, over here VG16. Then we just using the then COV dot class, COV underscore base, then flatten the dense, they will compile it. Okay, this is our sequential. Can see this is our VG16 flatten the dense underscore 1. Okay, step 5, we pre-processing the input data. Okay, we scale all the images, and we're using the train underscore generator, train underscore data dot flow from the tree. Actually, this is set as a pre-train model. Without a pre-train model, okay, target size we're using 150, batch 20. So after train generator and a validation generator, and then we'll start the training process. We're using same as the without a pre-train, we're using a steps per epoch 20, epochs we're using 30. Okay, start training. Then we plot the graph, plot the outcome. This is our overall outcomes. Okay, from here we can clearly see the training accuracy is very high. It's achieved the 100%, and then for the validation accuracy is over the 0.95. Okay, the lowest one is 0.95, and then for training and validation loss, we can see our training loss is 0, always in 0, and then for the validation loss, the highest one is 0.06. Actually, is considered as very low. Okay, as compared with the without a pre-train, okay, we can see the graph. Okay, 100%. With the VG16, we can increase the accuracy to 100%. Okay, and then lower the and decrease the validation loss or training loss into the 0. Okay, our training loss is 0. Okay, for with the VG16. So that's all for me. As a conclusion, for the VG16 actually can help to increase the accuracy of the train model. Thank you very much.
Assalamualaikum. My name is NURUL binti SULAIMAN, and my metric number is 8170014, and I will continue with the task 2, which is for the pre-train model, and we use Inception V3. So the first step is to link the Google Drive with the Google Colab, and the second step is for the data path directory, and the third step is for the train and validation directory. And we can see here the pet train length is 310, and the can train length is 156, and this is the pet val length is 133, and the can val length is 77. And for the step 4, which is for the Inception V3 pre-train model, and this is the command, which is we can see here for the train generator, we set the batch size is 20, and the target size is 150. And for the validation generator, the batch size is the same with training generator, which is 20, and the target size is the same, which is 150. And this is the command for to import the Inception V3. and the input shape is 150, 150, and 3. So as we can see here, it found that there is 466 images that belong to two classes and found 210 images which belong to two classes. And for the step 5 is to start the training, and we set the epoch for 30 and the step per epoch is 20. So this is the result for the training, where this is the validation, the training loss, training accuracy, the validation loss, and the validation accuracy. And this is the step 7, which is the outcome, and this is the command in order to get to plot the graph. So the first graph is for the training and validation accuracy. As we can see here, the training accuracy is reached the highest accuracy, which is higher than 0.5, and this is the highest validation accuracy, which is 1. So the next graph is for the training and validation loss. As we can see here, the lowest training loss is 0.1 and the lowest validation loss is 0. And we can see here for the graph for training accuracy and validation accuracy is optimum. And same with the training and validation loss, the graph for both graph is optimum. And to compare with the first task, which is to train without pre-trained model, the highest accuracy for training accuracy is 1, and the highest validation accuracy is higher than 0.9. And the result for the training and validation loss, the lowest training loss is 0, and the lowest validation loss is around 1.5. Okay, so to compare with the graph of inception, we can see for pre-trained model, the training accuracy graph is higher than validation accuracy, and the graph for training loss is lower than validation loss. And we can see here for training accuracy and validation accuracy, the graph is optimum. And same with the training loss and validation loss, the graph is optimum. So that's all for me. Thank you.
So for the task 3, we need to investigate a suitable method that able to identify and count the recyclable material. So as we know, computer vision plays a crucial role in many applications, including the facial recognition, image processing, factory analysis, and virtual reality. So ANR model, where nodes are attached to each other that sends data to each other. One of the methods that can be used is TensorFlow Object Detection API to train the model and use faster RCNN algorithm for implementation. This method is used to detect the classification an object or many image. This detection score is used between 0 and 1. This article is from Krishna and Sasikala from article Object Detection and Count of Object in Image using TensorFlow Object Detection. For the second article is Embedded CNN Based Vehicle Classification and Count in Non-Lane Road Traffic by Shwakan, Singh and Kenkar. The method it can be used in the second article is use classify an object is use YOLO pre-trained model as CNN based on image object detection. YOLO is known as model that give high object detection accuracy with a low interference latency. The object will be detected and divided into rectangular grid region for the probability of each region. This method can be used to classify and count every object in the image. As the conclusion, by using the appropriate value of each push and batch size, the final result we get the most accurate. We also learn how to do convolutional neural network CNN by using Google Colab, and also can run the programming command on Spider in Anaconda software. We learn to simulate using the VGG and having a higher accuracy as compared to the result of tuning without pre-trained model. We also learn to use inception while doing this assignment with almost accuracy 100%. Lastly, we learn to demonstrate the ability to solve the task, analyze the suitable algorithm based on the intelligent control system design for mechatronic application. So that's all from us. Thank you.